Hello. Thank you everyone for coming out today, and big thank you to Boris for lending me his computer to do this talk. I had a last-minute technical failure there, but I'm here now. And the talk I'm giving today is called Build Yourself Clean. Down here? That's all right. This way, there we go. Hey everyone. It's a silly name because when I was writing the abstract for this talk, I was listening to lots of LCD sound system, and I thought it would be really cool, but actually not in the end. What it is actually about is when you're building JavaScript or web applications, the build process to go from your source code to getting it running in the browser, and how we can do that in the best possible way. So we'll start just with about me. I'm a JavaScript developer. I'm Australian, but I live in Berlin, and I work for a company called SoundCloud, where I'm lead front-end developer on the new SoundCloud website, which is a single-page application that serves our entire site, entirely written in JavaScript. So let's get into it. I'll start with a short history of how JavaScript has been sort of delivered to the browser. And I don't think it's an understatement to say that, or it is a massive understatement to say the web has come a very long way. JavaScript was invented in 1995, and it was around this time that websites such as this were kind of considered cutting edge and cool. This is still actually online if you want to check it out. It's a really awesome site. But obviously around this time, because JavaScript was very new, there was no JavaScript being used in sites. Not long after this, sites such as Dynamic Drive sort of became a bit more popular, and people started to use JavaScript, but mostly for sort of toy scripts and annoying things like, everyone remember this? Yeah, it's cool stuff. And the important thing is not what it was being used for this talk, but how it was actually being delivered. And you can see the instructions are like, copy this code and paste it into your head. And so during this time, a lot of people didn't really understand it, and it was just inline scripts on a lot of pages. It was then, move that out of the way. It was then in 2004 when Google released Gmail that people actually kind of sat up and started paying attention to JavaScript. It was kind of the first big JavaScript application that got very popular. And while most people didn't quite get to the stage of building their own Gmail, people started using a lot more JavaScript in their applications, though at this time it was still, thankfully now, not inline scripts, but scripts in an actual file, but usually multiple scripts included in the head. A few years after this, around 2007 or so, people actually started to think about performance of getting the JavaScript to the browser. So people like Steve Souders started his blog on high-performance websites, and there were tools that were emerging, such as Yrself, which kind of pointed out the errors that we had in, or the areas that we can optimize on our website. So around this time, it became a lot more common for everyone to reduce HTTP requests by combining all of their files, and then minification became a lot more common, stripping out insignificant white space and comments, obviously. This kind of progressed for over the last few years until we get to the point today, which is that if you don't know what to uglify is, you're a simpleton, which is a quote, obviously, from Alice in Wonderland, believe it or not. And then in the last 2 years or so, modular code has really risen in JavaScript development. So tools such as Browserify or Require.js are very, very common. And people are developing in modules and using these to deliver their code to the browser. Modular code's got a lot of really good benefits to it, and you should really be looking into it. But in terms of how it can help you build, it actually really helps, because previous to this, you would normally just say, okay, take my entire source directory, combine all of the scripts there, and throw them across. But when you start to have modular code, you have an actual dependency tree. So you can actually then find exactly the files that you need, and the files that you don't need are not included. So that was very helpful. So that's where we are today, but what I'm talking about is where we can go from here. It's important to remember that a good build will do more than just reduce the file size and reduce the number of HTTP requests. So we already have that one down pat. Everyone is doing that. What we can do with our build is increase the network performance of our sites and also increase the runtime performance of our sites. So I'd like to go through a few of these techniques that we're using at SoundCloud on our JavaScript application, and hopefully you'd be able to apply these into your own applications. So the first one is asset hashing. So before I start on this, I'll just clarify what I mean by assets. Obviously, images everyone considers an asset, but you should also consider anything which is static after your build process. So that would include your JavaScript, your CSS, all files that are read from the disk are an asset. So I'm pretty sure that if anyone here has ever done any web development at some point, you've run into the problem where you've had your code as live, you've made some changes, pushed a new version, and your users have got a cached version of your website. You have to tell them, like, hold Command-Shift-R and stuff. So it's a real pain. So what people started to do, I hope that's readable, yeah, is do some sort of cache busting techniques. So adding a query parameter, just a dummy one, to the end of file names. It didn't actually change the file that was sent, but it hopefully busted the cache, and so you get a new version. There are a couple of problems with this technique, though, and it depends on how you actually get that number or that cache buster. If you're just increasing it every single time you deploy, that means that all of the valid caches of the assets which haven't changed have been invalidated. So you're actually you're losing an optimization there. And the other thing is that it actually isn't guaranteed to bust the cache. By default, you can set it up to do that, but by default, tools such as Varnish don't include the query parameter into the cache key. So I have a better solution, which is, first of all, when you're generating that counter, instead of using a counter or a timestamp or something, use something which actually identifies this version of the file with these contents. So you can use just like an MD5 checksum of the contents of the file, or even just look at the git commit history to find the latest commit which touched that file. And then during your build, when you're copying the assets from your source folder across to your target, actually write that into the file name of the file. The benefits of this are that you actually don't have to worry about caching anymore, because this file will never ever change. If you actually make change to the source file, you'll get a different output file. So all of your caching strategy is now cache everything forever. So that's very simple. Another benefit of this is that you can actually have multiple versions of the same assets sitting side by side. So if you just instead of wiping out your target directory, on your build, if you just keep adding into that same directory, you'll actually get sort of version history of all of those files. The reason why you might want to do this is especially important in single-page applications. When someone starts a session of your application, then they don't really hit your server again to get new code to run, which means that if that code is referring to an asset, and then you make a new deploy which changes that asset, they're going to get a 404 when they made that request for that image or the script. By putting all of them side by side, you can actually have multiple versions of your application running at the same time safely. At SoundCloud, we've actually seen it's not uncommon for people to have one session running for 4 or 5 weeks, which can be a real pain, I can tell you. The problem then, though, obviously, is that you have to then, if you're changing the file names of all of your assets every time you build, then you also need to change all the references to them. So somehow you have to go from myimage.jpg to myimage 1A, 2B, 3C JPEG. So the solution here is obviously we want to find and rewrite all of these references. Doing this in a CSS file or even in templates is rather easy. You can use just a regex for CSS or some DOM parsing to find references to assets in your HTML. But in JavaScript, it's not as simple as that because there are a lot of different ways that you might be defining what is essentially just a string. So what we've done is created a helper function that's __ asset. What it does, it simply just identifies strings which refer to an asset. That's the only thing that it does. So this is how we would use it if we wanted to do something in JavaScript with a particular file or an image. While we're developing, it's just an identity function that just returns that same string, because that's what it is on your local computer's disk. However, during production, we actually don't want to have this there. We want to have that replaced with the actual proper file name. So before I get into that, I'll just do a quick digression to talk about abstract syntax trees. This is something that we use a lot in the build scripts, and if you're using minification at all, tools like Uglify or Esprima will build an AST and use that to minify code. So an AST is just a representation of your code as a tree structure. So a very simple demonstration of this. So just this tiny snippet of code here with an if and 2 return statements might end up looking like this in an AST. So you can see there's each node, each part of that code has been built into a tree. When we have this tree, then it gives us a really good tool to be able to safely modify, adjust, and read code, knowing a lot more context than you would get from pure string manipulation. So getting back to our problem is that we have this asset just referenced with this helper function. So during the build script, we want to replace that. So this is going to be a bit ugly, but we'll go through what it looks like. The first thing is to actually build the AST. So I'm using here the Uglify library. So we get an AST, and then we ask to transform it. You can transform an AST by using a tree transformer object, which Uglify provides. This is simply something which just walks over the entire tree, and it gives you a callback function for every node that it hits. So inside our callback function, we check, is the node that we're on right now a call node? So that's a function call. And is the function that's being called, is it called asset? If it is, then we actually return a new object. So this is a new string that goes into its place. And here we simply create a string that has the value of the argument that's been passed into it, but with the asset hash added in there. You'll have to imagine that part. And then the output of this is just a literal string in your code. So then that's very easy and clean for the browser. It does have a small downside though, which is that you won't be able to dynamically reference your assets anymore. So you will sometimes have stuff like this in your code, where a simple for loop or using a variable would have actually generated this object a lot simpler. By doing this, you actually do have to literally list everything out. The reason for that is that during a build, your code isn't actually being executed, it's being statically analyzed. And so all of the information you draw out of it has to be actually in the code. It can't be executed. The small upside you get from this, though, is that by doing this, you've actually created a dependency tree that includes all of your assets, all of the images that are referenced, all through your entire application. And so then you can actually use that to your own benefit. For example, you can then find exactly which module references an image, and then even which images are no longer needed in your entire application. So it makes it very easy to refactor and clean up your repository. So the second thing is bucketing scripts. After passing across your entire directory to find the files that you need for your build, whether you're using modular code or you're just pointing it at a whole directory, the common thing that is done now is that you take all of those files, combine them all together, minify, and you create a single JavaScript file. At SoundCloud, what we do instead is we gather the files in the same way, but then we actually split them into 3 buckets. And we do this just with a simple regex. just on the file name of the file, and we create 3 separate output files. One for vendor files, one for our views and templates, and one for everything else. And there are 2 reasons that this is actually quite useful. The first thing is parallel loading. So when your index.html page is loaded, it then contains a reference to those 3 scripts, and the browser can actually go and pull them all at the same time. In effect, this means that it actually loads much faster by parallel loading there. And the other thing is that you can actually get much better caching by doing this. If you're using, like I said, even JavaScript files are considered assets, so they get this same hash in their file name. And it's quite uncommon that you would change, say, your vendor files. So between builds, your build will actually produce the exact same file with the exact same file name. And if someone is coming back to your site, they don't have to download that again. They'll just get the change in code. The third thing here is domain sharding. This is a technique that Steve Souders wrote about a few years ago and just recently had a revisit to this technique. It basically works on the knowledge that browsers will only open a certain number of parallel requests to a single host. So Chrome, Firefox, Safari, Opera will open only 6 requests to a single host. IE does 8, and IE11 does 11 per domain. But the point here is that there is a limit to that. He also did some research and found that of the top 300,000 websites, the median amount of requests made to a single host is 39. So that means 50% of websites actually make more than 39 requests to a single host. So when you combine that with the fact that the browser can only load 6 at a time, is that you get this effect. Then if you've ever opened the network panel in Chrome, you've probably seen something like this. Just a very simple representation of how the assets have been referenced and loaded here. So you can see at the start is your page being loaded, and it has then referenced a lot of images, scripts, style tags, and so on. And the 7th one there has to wait for a slot to open before it can start. Then the 8th has to wait, and so on, and you get this cascading effect. What domain sharding does is it actually, you split your assets across multiple domains to circumvent this limitation by the browser. And so if you were to put all of your assets split across about 4 domains or so, here in this example there's 3, they would all load in parallel. Obviously, you have limitations on the speed of your network, but those connections will all be happening at the same time, and in the end it goes much faster. There is a practical limit to how many domains you should actually split your assets across. Steve Souders did research on this and found that at about 4 is the right amount there. When you get above that, the number of DNS lookups that you have to do for these extra hosts outweighs the benefits of this technique. Obviously, then you have to figure out how to then change your assets to be on 4 different domains. This can just be a simple DNS record, which points 4 domains to point at the same directory on your server. But then your code needs to update as well. If you're using the asset technique I spoke about before, it's very simple then. Instead of just adding the hash into the file name, you just add the host to make it an absolute URL. One important thing here, though, is that you should make sure that the domain that you set your asset to is deterministic. So you don't want to do one build and this image ends up on a1.site.com, and the next time you build, it randomly assigns it to another one, because then you've actually invalidated the cache again. So just using a simple modular of the file name or its contents, it doesn't matter what, as long as it ends up on the same host. This one's a bit of a weird one, so you're going to have to bear with me on this. Something I just made up. I don't know if anyone's actually done this before or got a better name for it, but I'm calling it lazy require calls. This is, I would say, a pretty common pattern, not only in JavaScript when you're doing modular code there, but across a lot of different languages, that when you are writing a file, at the top of the file you include all of your imports. And then throughout the class or whatever you're defining, then you refer back to those imports that you've included. But if you look at this, at the top there, we've done 3 requires. However, 2 of them are actually only within an on-click handler, as an example. So it's not actually needed during the definition time of this module. They're only actually needed much later, and perhaps not even at all if the user never clicks on this view. And you have to remember that when the browser is running this code, it has to, so it'll find this require lib URL, and then it'll have to get that code and pass that, and that will probably have its subdependencies, and it will then go and find those and pass those ones, and so on and so on. So something which is actually quite small like this might end up being a lot of execution at the start of your application. So it can kind of cause a lot of performance problems there. So what I do here is another AST transformation. We do 2 passes over the tree. The first one is we find all of the variable declarations which are in this form of foo equals require bar. And then just create a mapping foo to bar. And then remove that call to require. Just drop that node from the tree altogether. And then the second step, we go through all of the variable references in the entire file. And anything which has referenced something which was required, we replace that with a call to require. And to save doing many, many calls every single time you want to reference a variable, we cache that as well. So this is what the output after running the transformation looks like. So like I said, it's a bit hard to read. Thankfully, you don't have to write like this. Your build script is what does it for you. But here you can see that the router and URL variables there are initialized completely empty, and then only once they're actually used is that call to require made. The second time that click happens, for example, the router variable is already populated, so that saves us that call. Targeted builds is something that I think is getting a bit more popular now, and people are starting to think more about this. What I mean by this is that you do a build specifically for a target environment. And by target environment, I mean a group of browsers. As I was saying, this is becoming a bit more popular. Recently, jQuery is now maintaining 2 versions, one for modern browsers, one for legacy browsers, IE 8 and below. And Lodash, the underscore replacement library, has got a lot of different builds, and you can specify mobile, for example, modern browsers only, compatibility, and so on. And that same technique can actually benefit your application as well. So all you have to do is choose your environments. So for example, if you have your website working for touch devices, mobile, you might want to not include that code for desktop browsers. So only include the touch library if the build environment is mobile. If you've got a build for legacy browsers, then you can include the code to maybe polyfill ES5 functions or so on. And then you could even use the other libraries' targeted builds in your own side. So obviously you wouldn't write code like this everywhere, but if you've got a build for modern browsers, then only include the Lodash modern build. If you're going legacy, then go the compatibility build. How this actually works, to go from this code here, you can see I've just used a variable here, __env. During the compression stage of the minification, you can just tell Uglify that this variable, let's say env, has a particular value, and it will substitute those with the literal value of this that you've told it here, so modern, and then it's able to do dead code removal and see that modern is not equal to legacy, and so that entire if statement is removed from the tree. So this is what we had before, and you can see that after the compression, that entire conditional has been removed. And when you, to actually get this going, and you'll end up with many different builds, one for each of your environments. You probably wouldn't want to go too crazy on that. But then in the browser, some simple browser sniffing or feature detection will let you know which one you have to then load. And the final thing that I'd like to talk about is page-specific packages. So what I mean by this is that instead of taking all of your files and either bucketing them or creating one file, split them up into two different categories, I'd say. Core files, which are the ones which are core to your application running, no matter what page you're on, and then ones which only apply to certain pages. Why would you want to do this, and when would you want to do this? When the total size of your application is becoming a little too large. What is too large is up to you. I would say when you're pushing about 1 megabyte of JavaScript after minification, that's getting pretty large. Right now, SoundCloud's got about 2 megabytes of JavaScript altogether across all of our application. And sites like Facebook, we've got about 2.2 megs, and Twitter, we've got about 1.5 megs, but just from loading the homepage. And the other thing is if you have low traffic site pages on your site, which include a lot of unique code. So for example, on SoundCloud, we have a page for the stats for a creator and also upload. These are pages which are not visited very often across all of our users, but they have a lot of code for graphing and so on. So we don't want everyone to be downloading D3 every time they want to just listen to a track. So what we're able to do is split them out into some code which is only loaded when it's needed. And then there's the how of how we do this. So these boxes here might represent all of the source code, all of the files you have in your source directory. The first thing you have to do is choose what I call some seeds. So here there's 3 highlighted. The yellow one we'll say is our application, like our bootstrap file. This is the core of the application that is what kicks everything off. Everything which it requires and everything which is required from those things must be loaded for your application to run at all. The green ones might be sort of, in our application we call them layouts, but that'd be the top level page view, for example, for each of the pages in your site. From there, you walk the tree of their dependencies, and you produce a graph that might look like this. You can see already that one of the files there isn't referenced by anything. That might be a test file, or it might be something which has been refactored out of use. And so we can actually remove that from the build altogether. But then we do sort of some tree walking and what's it called? Difference across the subtrees that you get there. And you can see we've colored in yellow here all of the modules that are required from the application file, and in green the ones which are only required by the layouts, by the page-specific ones. But that second one on the right, you can see, is required by both layouts. So why would we have that code defined twice? So we actually just pull that across into the core package. We don't do this for every single file, which is required by 2. We actually do a count across all of the nodes to see how many pages require a certain file. And once it gets above a threshold, then it is moved across into the core package to save duplicate code. For our application, we're using 4. So once a module is required by 4 pages, then it becomes core. And this is all done automatically during the build, so no one has to think, oh, this file belongs to this page or not. Whatever you use is automatically sorted. So wrapping up, I've just gone through a handful of techniques here, which we've found very useful at SoundCloud. And hopefully you'd be able to take some of these ideas and apply them to your own web application as well, to get it to load faster and run faster as well. Some of them might be useful, some of them might not, but I hope that I've planted the idea that you can actually get a lot more out of your build to get performance all the way through. So thank you very much. Any questions? Yes, Peter.
So these AST transformations seem really handy, and it's great that you don't have to do these by hand. But if you make some kind of error in your code and Sentry or whatever you use to track exceptions sends you an error report saying, yeah, there's an IE 3.2 browser out there that happens to have some kind of funky configuration and you happen to have some kind of JavaScript error, do you have any special tools that allow you to go back and reproduce that and figure out what's going on?
So you mean after transforming the code, you get something that doesn't look much like what you started?
Exactly.
And how do you go back? I would say that most people are already minifying code. It's a pretty standard problem, standard solution to the problem. And Chrome has source maps built into it. Obviously, IE 7 doesn't. And there you're out of luck, you really are. What we do to help a little bit is add line breaks when they're not actually needed, so that if there is an error report, we can narrow it down somewhat. But yeah, source maps will help in Chrome and Firefox. Unsupported browsers, you're kind of out of luck. The things I spoke about don't make them that much worse. Yeah, it's an already existing problem.
Thanks.
I think I'm down here.
Can we find this code online somewhere? Did you publish this as some like grand tasks or something?
Unfortunately, I haven't actually published any of this online. The entire build script for our application, I'd really like to do that, except in the interest of actually making it work, there's a lot of stuff that is, like, I know that this file is in this directory and it has to do this sort of thing, so it was just easier to kind of hard code stuff. Yeah, it's something that could be done, and a lot of people have actually built parts of this individually. So if you look, there's a lot of Node NPM modules that do individual parts of this. Browserify, for example, does the page-specific layouts. It doesn't do the reference counting to sort of move commonly used ones into the application, but bits and pieces are around the place.
Okay, so. Thanks.
About the domain sharding, do you have any knowledge why there's such a low limit in the first place? It looks like we are trying to solve a problem which shouldn't be there in the first place anyway.
I'm not exactly sure why the browsers did this. Up until recently, it was only 2 per domain, which is a real problem. I think it's basically so so you don't include some third-party script or something which then floods your entire all your browser's connection. I have no insight into why it's a limitation, but it's there and it's across all of the browsers. Yep, behind you, just there. Oh, sorry.
I see you are doing resource hashing. We actually are doing the same solution for our assets, but you have a single page application. But the thing about your application, the specific thing is that the users are connected for hours.
Yeah, or weeks.
Or weeks, yeah. I saw that when you make an update to the application, you get like a small bar in the side suggesting the user to refresh the page.
Yes.
What happens when you don't have the option of suggesting the user that he should be refreshing? I mean, when you have a hotfix or something like that.
I missed that last bit. When
you have a hotfix, you have a real problem with the page.
Oh, right.
Shit happens, and you have to force the users.
We need to stop a particular version, you mean?
Yeah.
So this has happened to us once or twice. We've accidentally deployed a self-DDoS, which was really fun. And so what we have in the application is something that pings back. So in our build, we write a version number to a file. And then every 10 minutes, all of the applications ask for that file, and if the version number's changed, then we suggest, because on our site people are listening to music, we don't want to just refresh, that would be really annoying. So we suggest they reload the page whenever they want. and in our build, you can set an emergency flag. So that adds like a special character to the version file. And if the application gets that, then it just does a hard refresh straight away.
Okay, thanks.
Yeah.
Are you using any particular tools for the build? I mean, when you create the build, are you doing it on the server, or are you using something like require.js, or I mean, what tooling are you using around it?
Sure. So our build script is written in Node.js. I'd recommend using Node.js for this. Using JavaScript to modify JavaScript is really good, and obviously a lot of JavaScript developers are working with it. So there's a lot of good tools, and it's growing. How it actually runs is that it's just a script that we run on the command line, and we just have a make file which just kicks that off. It's not run on the servers which send the files. It's kind of a bit more complicated. That we build the files, put it into a Linux container, and then put that onto our CDN. Obviously, that's not going to apply everywhere, though.
Yeah, I want to ask you, how do you manage dependencies between modules? You have a core application where you use ground build, I suppose, but how do you include the sub-modules and use Bower, for example, for front-end code? I don't know.
I'm not sure I understand your question, sorry.
Okay, because I have a single-page application which spreads across several modules, and when I do a single JavaScript file using Grunt, I have the problem that there are no, you have to include the relative paths of modules. So
well, we don't actually do that. We use absolute paths for all of our modules. Although, I mean, there's no reason you couldn't use relative paths. The RJS tool, for example, which comes with require.js, will find all of the references that are relative and actually rewrite them to be the full path. I've found it simpler to just write the full path out. I don't see any need for the relative stuff, actually.
okay, thanks.
So you're using then require.js for the front end? For managing modules on the front end?
Require.js, yeah.
Cool.
In production, it's Almond.js. It's very lightweight. It's not a dynamic loader like require.js is. It loads modules which are already defined. Yeah.
Okay, cool.
If there are no more questions, then thank you.
3, 2, 1. Thank you very much.